But actually, I mean, this is of course an old trick from Monte Carlo. And this is again 90s or so stuff, and particle filters became available. That on its own doesn't cure. I mean, it helps a little bit, but it doesn't cure the curse of dimensionality. So you have to work a little bit harder. Here's again in a bit more abstract way. This is this change in measure you get from using a control law and the corresponding Radon-Nikodym derivative or likelihood is this, and you want this to match essentially the change of measure you get from the data assimilation step. And the optimal choice is this. So what Peter Jan is working on and others is sort of, so in a way, go beyond this by using other proposal steps that also take the whole ensemble again into account. But in a quintessence, it's this idea, right? I mean, you use the freedom that the model gives you, existence of model errors, to steer yourself towards regions of high probability. And as I also mentioned earlier, this idea appears in rare event simulations. It appears in molecular simulations. Whenever essentially you want to simulate something that's not natural or not high probability event with regard to the original dynamics, like a rare transition in a molecular system, like a folding process or something, et cetera, et cetera. So these techniques are of importance to a lot of fields. Right, and again, there are some references here. So this is Peter Jan survey paper. Then this hybrid stuff in here. This is the work I mentioned, Künsch, on this hybrid. That's again a sort of a survey paper. It's a very nice one. They mention it. I mean, they give some details on this hybrid as well, but they're also surveying the particle filters and other things. Now there's work by Stewart and others on effective dimensions, because this is really what matters. That relates back to this coefficient rho, the importance sampling. I mean, how much does it collapse? That depends on properties of your prior and the likelihood and their mutual relationships, etc. So they did quite a careful study on this. And there's also a very nice survey on variational techniques and ensemble extensions, and smoothing, and et cetera, et cetera. It's Bannister. And with this, I'd like to finish.